Hi guys, welcome back to my YouTube channel. My name is Dhanushar. I'm studying in Sri Venkateswara College of Engineering, as you all know. And today our subject is digital design and computer organization. In that, our topic is evolution of digital IC technologies and its naming patterns. In that, we are going to know about the introduction about the digital IC technologies. IC is nothing but integrated circuits. Digital integrated circuits, ICs, are foundational components in modern electronics. You can see there is a chip that is called the IC integrated circuits here. The right side in the diagram, we can see the silicon chip here and the wire connected to the silicon chip. That is a circuit. It is a IC circuit. They combine multiple functions into a single chip, enhancing performance and reducing the size. We can reduce the size by enhancing the connections between them, and we can combine multiple functions into a single chip. You can see as in a diagram. Understanding their evolution helps in grasping and advancements in technology and naming conventions. The next is early developments in digital ICs, integrated circuits. The first digital ICs emerged in 1960s, primarily using bipolar technology. In the 1960s itself, it has introduced, developed at the first time. These early chips enabled basic computational functions, paving the way of modern computing. And the initial naming conventions were often based on the functionality or logic family, such as TTL. The transistors logic, transistor to transistor logic. Shift to CMOS technology, complementary metal oxide semiconductors. In 1970s, we have introduced the CMOS, that is complementary metal oxide semiconductor. It is very flexible and it is very much simple before after which have made with the semiconductor technology began to dominate. We have already dominated the environment using our technology. CMOS offered significant power savings and higher integration densities compared to bipolar counterparts. And the naming conventions transitioned to include references to CMOS as we have seen in the 74HC series, which indicates high speed CMOS chips. The rise of programmable logic devices. The 1980s saw the introduction of programmable logic devices, PLDs, programmable logic devices, such as the FPGAs and the CPLDs. These devices allowed user to configure logic functions and on demand, revolutionizing the circuit design. Naming patterns for PLEDs often included references to their configurability, such as flex and ultra. Advancement of technology nodes. In 1990s and 2000s marked a transition to smaller technology nodes, enabling more complex designs. We have designed more complexes on 1990s and 2000s. Naming conventions began to incorporate the process technologies size like 90 nm and 65 nm and so on. It's 95 nm is 90 nanometer and 65 nm is 65 nm is 65 nanometer and so on. As nodes shrank, manufacturers started to emphasize performance matrices and power efficiency in their product names. Integration of mixed signal ICs. The integration of analog and digital functions led to the development of mixed signal ICs. I mean integrated circuits. In late 1990s, we have developed many circuits in the 1990s and 2000s. In that, the integration of an analog of and the digital functions led to the development of a mixed signals is in the 1990s itself. These ICs are crucial for applications such as data conversion and signal processing. We can use these ICs as applications for the data conversions, and we can convert the data, and for the signal processing. We are nowadays we are using the cell phone for that the signal should be needed, so we can use the ICs for the signal processing. Naming conventions often reflect their mixed capabilities, and with designations like ADC, analog to digital converter, and the DCA, that is the digital to analog. We can convert the analog to digital converter, and we can convert the digital to the analog. That is called the ADC and the DAC. And it is system on chip, that is SoC revolution. System on chip revolution in 2000s, the ushered in era of a system on chips, system on chips, that is SoCs designs integrating entire systems onto a single chip. The SoCs combine processors, memory, and peripheral optimizing performance and power consumption. That there are many, that is processors like like processors, memory, peripheral, and optimizing performances and the power consumptions are needed. The in the and the last is the naming conventions evolved to highlight the integration and often using terms like system on chips or specific application names. Here we can see the highlights of the integration often using like terms. We can use the system on chips or specific application names. Future trends and naming patterns. The future trends and the naming patterns as technology advances, as technology advances, trends like 3D stacking and heterogeneous integration are becoming prominent. Future naming patterns may reflect functionality, integration levels, and new architectures such as AI and quantum computing. It's a very great as quantum computing is implementing. Keeping abreast of these changes is a crucial for engineers as they influence design choices and market competitives. Thank you. Thank you for listening my video. Please like the video.